We now study the trigonometric functions. So we start by defining the sine and cosine functions. So to do so, we begin by drawing a unit circle, which is a circle of radius 1 and is centered at the origin as shown here. The angle in radians that t intercepts forms an arc of length s. Right, so have an angle t, this is the radius. It intersects the circle at some point x comma y, and this has a length of s. So we already know that s equals r times t. And since r equals 1, we can conclude that s is equal to t. For any angle t, we can then label the intersection of the terminal side and unit circle by its coordinates x comma y. The sine function relates a real number t to the y-coordinate of the point where the corresponding angle intercepts the unit circle. More precisely, sine of t is the y-coordinate of the endpoint on the unit circle of an arc length of t. So we have our ray, we have our terminal side of angle t, we draw that radius, it intersects the unit circle at point xy, sine of that angle is the y-coordinate of that point of intersection. The cosine function relates a real number t to the x-coordinate of the point where the corresponding angle intercepts the unit circle. So more precisely, cosine of t is the x-coordinate of the endpoint on the unit circle of an arc length of t. Right, so again, this is the angle t. This is the terminal side. That radius intersects the unit circle at point xy. So the cosine of that angle is this x-coordinate right here. So let's go ahead and evaluate the cosine of 90 degrees and the sine of 90 degrees. So to do this, let's draw a unit circle. So here's the upper half unit circle. And here is our lower half. So 90 degrees, remember, the positive x-axis is always our initial side. So what we need to do is we need to take the terminal side, which also starts here, and rotate 90 degrees. That would be up here, right? The positive y-axis. So this angle right here is our 90 degrees. Well, this here is the point 1 on the y-axis, so x is 0, y is 1. So right away we can conclude that the cosine of 90 degrees is 0, and the sine of 90 degrees is 1. Right, so these two values will be important, and we will see why a little bit later. Now, the equation of the unit circle is x squared plus y squared is equal to 1. But x is cosine of t, and y is sine of t. And so we can write cosine squared of t plus sine squared of t is equal to 1. This is one of the most important trigonometric identities, and it is known as the Pythagorean identity. It's actually one of 3 Pythagorean identities. We will derive the other 2 a little bit later in the video. Actually, I believe it's towards the end of this video we will derive the other 2. So we're going to obviously be using this identity now to calculate or evaluate cosine 45 and sine of 45. So again, we want to start by drawing our unit circle. Okay, so 45 degrees be right about here. Now, since it is the unit circle, we know that this length right here is going to be 1. So here's what we can now draw. We now have a right triangle. Right? Here's x, here's y. Now, we're actually not going to be using the right triangle, other than to say that since it is a right triangle, it is a 45, 45, 90. So x has to be equal to y here. So since we have a 45, 45, 90 right triangle, x is equal to y. Therefore, x squared plus y squared is equal to 1 means that 2x squared is equal to 1. So this means that x squared itself would have to be equal to a half. So x is plus or minus 1 over the square root of 2, or plus or minus root 2 over 2. However, x has to be greater than 0, so this means that x would equal positive root 2 over 2, which means that the cosine of 45 degrees is equal to root 2 over 2. Now, since x equals y has to equal root 2 over 2. And so that means that sine of 45 degrees is root 2 over 2. Right? So these are our values. Both cosine and sine of 45 degrees is root 2 over 2. Now let's go ahead and evaluate the cosine and sine of 30 degrees. And again, as we did in the last one, start with our unit circle. Okay, so here's our unit circle. We need to draw the 30-degree angle. So that's probably something like this. And again, that has to have a length of 1 because it's the unit circle. So now what we can do is let's draw a line all the way down like this. Then we have a radius connecting down there. And we'll have this line right here, and I will shade this in yellow as well, just to complete our triangle. Now here are two 90-degree angles. Since this is 30 degrees here, this one here would also be 30 degrees, so total this is 60. So this is a 60, 60, 60 triangle. But if we look just up here, we have a 30, 60, 90 triangle. So we have two 30, 60, 90 triangles. If we look at them as a single, it becomes a 60, 60, 60, which is an equilateral triangle. So this means that all lengths must be equal. So this length here must be equal to this length right here. Well, half of it's y, right? So 1 must be equal to 2y, which means that y itself is equal to 1/2. This means that the sine of 30 degrees is equal to 1/2. We now use the Pythagorean identity. Cosine squared of 30 degrees plus sine squared of 30 degrees must be equal to 1. So that means that the cosine squared of 30 degrees plus a quarter must be equal to 1. So the cosine squared of 30 degrees must be equal to 3/4. And so cosine of 30 degrees would have to be plus or minus √3/2. However, we're dealing with quadrant 1. So we take this to be cosine of 30 degrees is equal to the square root of 3/2. So sine of 30 is 1/2. Cosine of 30 is √3/2. Let's now look at cosine of 60 degrees and sine of 60 degrees. So as before, we start with our unit circle. So we need to draw 60 degrees. It'll probably be something like this. Again, that radius has length 1. So what we can do now is draw this line here. We can now draw another radius along the x-axis, and if we connect that to the point of intersection, we now have this triangle. Now again, we have two 30, 60, 90. So we have a single 60, 60, 60 triangle. Again, this means that all lengths must be equal. Which means that this length down here is obviously 1, but this is x and x, so this is 2x here. So we have 1 has to be 2x, which means that x has to be 1/2, which means that cosine of 60 degrees has to be 1/2. Well, from the previous problem, we conclude that the sine of 60 degrees must be the square root of 3 over 2. Right? Because if we go back and we look at the previous example, right here, right, notice sine of 30 was 1/2. When you did the math with Pythagorean Identity, we got cosine of 33 over 2. Here we have cosine as 1/2. Well, the work is going to be exactly the same. So sine of 60 must be root 3 over 2. So these angles, along with 0 degrees, are summarized here. So cosine of 0 is 1, sine of 0 is 0. Cosine of 30 is root 3 over 2, sine of 30 is 1/2. Cosine of 45 is root 2 over 2, sine of 45 is root 2 over 2. Cosine of 60 is 1/2, sine of 60 is root 3 over 2. Cosine of 90 is 0, sine of 90 is 1. So this example is asking us to evaluate cosine of 5 pi over 3 and sine of 5 pi over 3 using a calculator. The next video will go over this. So we'll come back to this example in the next video. From our discussion so far, we can determine the domain of sine and cosine is all real numbers, and the range is -1 to 1. So the previous examples and the summary slide gives the values for several important angles. In fact, we really only need to know these values. Then by using appropriate properties, we can determine the sine and cosine of just about any angle. So the first property we look at was studied previously, that was the Pythagorean. If we wish to find the sine and cosine of an angle in a quadrant other than quadrant 1, we would do this by referring to the angle's reference angle. And remember, the reference angle is the acute angle that is measured from the horizontal axis. So here we have a summary of it. If our angle is located in quadrant 1, then our reference angle is just the original angle. If our angle is in quadrant 2, then our reference angle is measured from the negative x-axis in a clockwise direction. And we'll find, if we look, this has to be 180 degrees, this entire line. So our reference angle would have to be 180 degrees minus our original angle. If our angle is a third quadrant angle, our reference angle is measured from the negative x-axis in a counterclockwise direction. Now, this angle here would have to be 270, right? But this angle here is 180. So this angle would be the total angle T minus the 180, right? And that's how you get T prime, the reference angle. If our angle is in the fourth quadrant, then our reference angle is measured from the positive in a clockwise direction. Right? Now, the whole unit circle is 360 degrees. So our reference angle would be the 2 pi, the 360 degrees, minus this t, this original angle. And again, that is all summarized down here for you. So let's find the reference angle of 225 degrees. Okay, so we look, the angle 225, right? Well, this is 180, this is 270, so it's going to be about halfway between. Right? So this here measures the 225 degrees. So our reference angle will be this angle right here, which let's label that as phi. It's a quadrant 3, so this means that angle phi is equal to the original angle, 225, minus 180, and that difference is 45 degrees. So the reference angle of 225 degrees is 45 degrees. So let's go ahead and use reference angles to evaluate cosine of 5 pi over 4 and sine of 5 pi over 4. So let's go ahead and draw our reference angle. So 5 pi over 4, this line right here would represent pi. 5 pi over 4 is greater than that, but less than 3 pi over 2. So 5 pi over 4 would be somewhere in quadrant 3. So if we wish to find our reference angle, call it phi, right? So phi is 5 pi minus 4 minus pi. This gives us pi over 4. Now, we also note that 5 pi over 4 is in quadrant 3, right? So cosine would have to be less than 0, and sine is also less than 0. So doing this, we find that cosine of 5 pi over 4 is equal to negative cosine of pi over 4. And that we found was root 2 over 2. So cosine of 5 pi over 4 is negative root 2 over 2. Sine of 5 pi over 4 would be negative sine of pi over 4. And again, sine of pi over 4 was the square root of 2 over 2. So sine of 5 pi over 4 is negative square root of 2 over 2. We will now look at the remaining 4 trigonometric functions. They are the tangent, the secant, the cosecant, and the cotangent. Once again, we will turn to the unit circle to define these. So let xy be the point on the unit circle that corresponds to an angle t. We then define the tangent function as the ratio of the y value to the x value. So that is, it is y over x. The secant function is the reciprocal of the x value, so that is 1 over x. The cosecant is the reciprocal of the y value, so that is 1 over y. And the cotangent is the ratio of the x to the y, so that is x over y. Now, fundamental identities. So from these two, or from these four, plus the definition of sine and cosine, we can easily come up with these four fundamental identities. That the tangent is equal to the sine over the cosine, the secant is equal to the 1 over the cosine, the cosecant is equal to the 1 over the sine, and the cotangent is equal to the cosine over the sine. We will use these four fundamental identities to now evaluate tangent, secant, cosecant, and cotangent for the 5 fundamental angles that we studied. So 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So start with 0 degrees. So tangent of 0 is sine of 0 over cosine of 0. Right, the sine of 0 was 0. Cosine of 0 is 1, so that is 0. The secant of 0 degrees is 1 over the cosine of 0 degrees. Cosine of 0 is 1, and so the secant is 1. The cosecant of 0 degrees is 1 over the sine of 0 degrees. This gives us 1 over 0, which is undefined. Right? We're not allowed to divide by 0. And finally, cotangent of 0 degrees is cosine of 0 over sine of 0. This again gives us 1 over 0, which is, again, undefined. If we now look at 30 degrees, so tangent 30 degrees, that's sine of 30 over cosine of 30. So the sine of 30 was a half, cosine of 30 was root 3 over 2. So this is 1 over the square root of 3, or square root of 3 over 3. Secant of 30 degrees was 1 over the cosine of 30. So this is 1 over the square root of 3 over 2, which is 2 over root 3, or 2 root 3 over 3. Cosecant of 30 degrees is 1 over sine of 30. So it's 1 over a half, which is equal to 2. And finally, the cotangent of 30 degrees is the sine of 30 over the cosine of 30. I'm sorry, I got that backwards. It's the cosine of 30 over the sine of 30. So that is root 3 over 2 divided by a half, and that is simply the square root of 3. If we now move on to 45 degrees, tangent of 45 degrees is equal to sine of 45 over the cosine of 45. So it's root 2 over 2 divided by root 2 over 2. That is just 1. The secant of 45 degrees would be 1 over the cosine of 45. So that's 1 over root 2 over 2, which is 2 over root 2, or simply the square root of 2. The cosecant of 45 degrees was 1 over the sine of 45, but the sine of 45 and the cosine are the same, so this is also root 2. And finally, the cotangent of 45 degrees is cosine of 45 divided by sine of 45. Right, well, that's just going to be 1. If we now look at 60, so tangent of 60 degrees is sine of 60 over cosine of 60. So we get root 3 over 2 divided by a half, which is just root 3. Secant of 60 degrees is 1 over the cosine of 60. So we get 1 over a half, which is just 2. The cosecant of 60 degrees, 1 over the sine of 60. So 1 over root 3 over 2, 2 over the square root of 3, or 2 root 3 over 3. And finally, the cotangent of 60 degrees, cosine of 60 over the sine of 60. So it's a half over root 3 over 2, 1 over root 3, or root 3 over 3. And finally, we have 90 degrees. So tangent 90, sine of 90, over cosine of 90. Right, sine of 90 is 1, cosine of 90 is 0. This is undefined. Secant of 90, 1 over cosine of 90, which is 1 over 0, which is undefined. Cosecant of 90, 1 over sine of 90, so 1 over 1, which is 1. And finally, cotangent of 90, cosine of 90 over sine of 90, 0 over 1, which is 0. We now wish to evaluate the 6 trigonometric functions at negative 5 pi over 6. So again, we're going to do this using reference angles. So if we draw our angle, negative 5 pi over 6, so we're going clockwise. So down here we have negative pi over 2. This is negative pi. Right, so negative 5 pi over 6 is going to be somewhere between these two. Let's just say that. So the reference angle we need is this one right here, right, which is phi. So what we can do is if we look, this whole thing is negative pi. So it'll be negative 5 pi over 6 plus that minus that negative pi. Right, so our reference angle phi would be negative 5 pi over 6 plus pi, which is pi over 6. Another way you could do it is to look at this angle here, so you have to add 2 pi first to get the coterminal angle to make it positive, and then it's quadrant 3, so you do that angle minus pi. So sine negative 5 pi over 6. We're in the third quadrant, so both sine and cosine are negative. So we have negative 1/2 cosine of minus 5 pi over 6 be negative cosine of pi over 6. So negative root 3 over 2. Tan negative 5 pi over 6 is negative tangent of pi over 6. Right? So we'll get, what is it, negative 1/2 over negative root 3 over 2. This will wind up being positive, and it should be 1 over root 3, or simply root 3 over 3. So I'm sorry, tangent's actually not negative here. This is positive tangent, right? Because in quadrant 3, both sine and cosine are negative, which leaves a positive tangent. If we look at the secant of negative 5 pi over 6, that's going to be 1 over cosine, so it'd be negative 2 over root 3, or negative 2 root 3 over 3. Cosecant, negative 5 pi over 6 is 1 over negative sine, so it's negative 2. And finally, the cotangent of negative 5 pi over 6 is going to be 1 over the tangent, so it would be square root of 3. So again, in the next video, we will look at this example, so using technology to calculate the trigonometric functions at a specific angle. All right, so more properties. The sine function is an odd function, and the cosine function is an even function. So two more identities. These are the Pythagorean identities, the other two. So we're going to derive these. So first, with 1 plus tangent squared equals secant squared, we will start with cosine squared plus sine squared is equal to 1. Divide everything by cosine squared. So we get cosine squared t over cosine squared t plus sine squared t over cosine squared t is equal to 1 over cosine squared t. So cosine over cosine is 1. Sine over cosine is tangent. And 1 over cosine is secant. For the other one, we again start with cosine squared plus sine squared is equal to 1. This time we divide everything by sine squared. Cosine squared over sine squared is cotangent squared. Sine over sine is 1, and 1 over sine is cosecant. And so there are those two identities. We conclude by looking at periodicity. So we say that a function that repeats its values in regular intervals is a periodic function. The period of a periodic function is the shortest interval over which the function completes one full cycle. In other words, the period of a periodic function is the smallest number p such that f of x plus p is equal to f of x for any value of x in the domain of f. So from our understanding of the trigonometric functions, we find that sine, cosine, secant, and cosecant functions are all 2 pi periodic, while the tangent and cotangent functions are all pi periodic. So that concludes our introduction into the 6 trigonometric functions. In the next video, we will continue to study these 6 trigonometric functions.